Hi there. It's hard to believe that it's week 10 already. Only a month to go and the semester will be over. Thanks to all of you for your efforts and thanks for hanging in there for the semester. I hope that you've learned a lot. This week's topic is groundwater, which is my specialty. So it's been hard for me to decide what to tell you about groundwater. I think what I'm going to do is tell you why I fell in love with groundwater, why I got a PhD in it, um, how important it is to all of us, and what my PhD focused on because I think it's a fascinating area of research. Believe it or not, of the available fresh water on the planet that's in liquid form, 97% of it is underground, groundwater in aquifers. Only 3% is in surface water, lakes, streams, rivers. So imagine all of the lakes and streams and rivers on the planet and then multiply that. That's only 3%. And then 97%, how many times more is that, is under the ground? How did it get there? Well, there are a bunch of different ways, but basically, the geological structure is porous. So it allows for water to be held in what are called aquifers. So when you think of an aquifer, when I first got into groundwater, I thought an aquifer was a pristine little lake just under the ground, and you tapped into it for your well, and that's where you got your fresh water. No, that's not right. You can think of an aquifer as a rocky sponge. You know how a sponge has so many holes in it, and so it holds water? Well, there are certain rocks like sandstone that are exactly the same way. They hold the water. And then under pressure, they can release the water. Groundwater is everywhere. It's shocking how prevalent it is. And especially here in Pennsylvania, because we have a lot of sandstone, there is a lot of groundwater. Anytime someone digs a well to get fresh water for their home or other purpose, they are tapping into groundwater. What I particularly love about groundwater is the mystery of the hydrogeology. That's what the rock-bearing formations or the water-bearing rock formations are called. It's hydrogeology. So for me, it's almost magical to think of these layers of rocks under the ground, under the surface, that are holding water. And so you can have a layer of rock that is holding water and it's going along very smoothly. But then, because of some earthquake or something, millions of years ago, that layer will shift. And so the water bearing layer will be here, but then it'll be here too. And so the water bearing layer just sort of ends, right here. I just love almost everything about hydrogeology and groundwater. Um, the vast portion of water that is used for agriculture comes from groundwater. My LLM thesis was on fossil aquifers, which are aquifers that are obviously under the ground, but the water was put into place thousands to millions of years ago. There are a few fossil aquifers around. Some of the larger ones are in the US and the Midwest, in China, in Northern Africa, which, believe it or not, used to be a tropical area with lots and lots of water. There's one that's shared by 4 countries in Latin America: Brazil, Uruguay, Paraguay, and Argentina. That's a very, very large one. It was actually the discovery of the Ogallala Aquifer in the Midwest of the United States that turned what was the Dust Bowl in the 1920s into today's Farm Belt. Unfortunately, with fossil aquifers, they don't replenish. So any extraction is actually mining the resource. And the water table of the Ogallala is decreasing because it's been pumped so much for agriculture. In some areas, they can't use it anymore. Some areas of Kansas and Texas and Colorado. Another thing about groundwater is that it replenishes streams and rivers. So the water escapes from underground and runs into streams, rivers, lakes. And some areas of Colorado are seeing streams that are no longer being replenished by the Ogallala water. There can be layers of aquifers. For example, under Long Island, there is an aquifer, I have to use my hands, that is at the very surface that is replenished by the rain. So that one is used a lot for drinking water for residences. Then underneath that aquifer is another aquifer. And between the two is a confining layer of impermeable rock. Often that impermeable rock consists of clay because water can't get through clay. So you have this non-recharging, well, minimally recharging aquifer under the recharging aquifer that is recharged from the rain, all right? Then underneath that, you have a third aquifer, which is a fossil aquifer, where the water is 6,000 years old. That water was put into place during, I guess, during the end of the glacial period. That one is fully confined. It does not replenish at all, does not recharge. And I guess the policy on Long Island is to not tap that fossil aquifer, but to keep it for future generations, which is what I argued in my LLM thesis. So I'm very, very happy to hear that. My PhD was on offshore fossil aquifers. These aquifers were put into place when the sea levels were a lot lower during the last glacial maximum, when so much of the Earth's water was caught up in the polar caps and glaciers. So the water levels were the sea levels were so much lower that what are now submerged continental shelves were actually exposed land. The aquifers were put into place, confining layers, clay and other things, moved on top through natural erosion and natural processes. And then during the interglacial period, the sea levels rose and covered these continental shelves that still hold a lot of fresh water. There is a an offshore fossil aquifer. Well, they're all over the world. They're under continental shelves all over the world. There is one that is off the northeast coast of the United States that has a fresh water volume equivalent to that of Lake Ontario. That is a lot of water. So, like I said, I have fallen in love with aquifers. I don't expect all of you to, but I would like for you to have an appreciation of that particular freshwater resource. Once again, if you have any questions, let me know and feel free to join the office hour on Zoom Tuesdays at 5 o'clock. Thank you. Bye.